Hello, I'm Jack Rickard. This is Electric Vehicle Television. I'm here with Bob Wilson. Bob, I understand our numbers are in and our female viewership is up 11,000%.
We've doubled at least.
We have 5 of them now.
Oh, really?
And apparently it's all about you.
Yep. Come on. Hopefully we have at least one, which is my baby Ronna Jean.
I think she's got 2 friends.
Yeah. I think they watch maybe the first 30 seconds and go, oh, there's Bobby,
right,
and then, you know.
That's pretty much it.
We watched it. We saw you this week.
I don't really have anything to talk about, so I'm ready to go home. Mm-hmm. We'll play the music and get out of here.
Okay, thanks for coming.
Unless you've got something you want to talk about.
Oh, just a couple things. Not much. It's pretty
lightweight.
Out there. So, you know, if you've always wanted to own a Tesla but you couldn't afford it, well, now you can. Matchbox and Hot Wheels now have a Tesla Model S that you too can own.
Is that right?
Yes.
Well, they've made the big time, and they are actually an automotive manufacturer.
Right.
If there's a Hot Wheels and a Matchbox of one of their models, they're pretty much it.
Yep, they've hit it.
So that's the end of the question of whether Tesla can make it as an auto manufacturer.
They are real now.
Are these electric, or you still have to push them?
You still got to push them, yeah.
Okay.
And we've got a picture of the Matchbox because it looks quite a bit better than the Hot Wheels.
You think so?
Yeah. And I was always a Hot Wheels fan over the Matchbox.
Really?
But, yeah. At any rate,
they've been competing for many, many years.
They've forever. Yeah. Well, you too can have one.
What does it cost?
Good question. I don't know.
This whole news thing, you gotta
I gotta do a little deeper research.
Yeah,
I'm a headline news guy.
Is that try to imagine questions that people like me might have.
What colors do they come in?
Right. What colors?
Can I get wheels? Different wheels?
How much are they?
At your local Matchbox outlet.
and I like to throw in a little trivia about when Hot Wheels started or when Matchbox started. And
Fair enough.
When the other one went against them and how they used to be brother-in-laws or something, and then there was a big split. And, you know, the whole Matchbox, Hot Wheels dynasty thing.
Sure.
You know, a little history of that.
It's out there.
I mean, like when they have the Aerial America show, they don't just like fly over America and take video. They tell you a little bit about
a little backstory.
A little backstory about whatever they're showing.
Well, you all remember playing with Hot Wheels and Matchbox as a kid, with those, and you can now get a Tesla.
Let's work on these stories a little.
Okay. We'll get a little deeper
when you get into this. Yeah.
In other news, or similar news with the Teslas, you've even mentioned they have the new Supercharger that is liquid cooled, which runs with a smaller cable. In fact, it has a new handle that doesn't have the button on it, or the expose button. It's all kind of built into the handle now. And anyway, we've got a video of a guy that in Mountain View that kind of talks about the new Charger and how it runs, and if it is in fact cooler. In fact, he has a thermal image on the Charger, and to see what it looks like.
If you'll contact him and get permission to use the video,
it's on YouTube.
Well, even then, I saw it, and this is a private individual. You need to talk to him.
Okay.
And so if you'll get his permission, I'll put her in right here.
Okay.
If we don't put her in right here, Bob didn't do his homework.
Okay. So, trust me on this. It's actually not even that interesting, but at any rate.
This is a little too awesome to wait until our road trip is over to share. But this is Mountain View, California, home of Tesla's first public liquid-cooled superchargers. Look how thin that cable is. It's flexible. And you notice something's missing here. Come on. It's really bright out. There's no buttons. Well, there is, but it's solid. There's no outer tab. The stations are a little different. It's along the lines of the new style they've been doing. Down at the bottom, though, is radiator slots on both sides. Nothing at the top. So other than the radiator slots at the bottom, that's pretty much it. I'm going to do another video now with my thermal imagery and see what comes up. Although I don't need too much of a charge, maybe I shouldn't have gotten such a big charge at the factory. We are at Tesla's first liquid-cooled public charging superchargers. Now I just plugged in for mine. You can hear the fans cooling and going, but this nice car over here has been in for a while, so let's just see. You can see some heat coming out of there. It's up to 90. Let's see the cable's at 102. It's actually significantly cooler than what I usually record on non-liquid cooled superchargers. Nothing too significant. Let's go back to the station we're at. And it is surprisingly cool. Let's just see how we're heating up in the front here. And my car's got the cooling fans going. Starting to heat up a little bit there. Car's fans going. Say hi, Vinny.
I'm coming to you.
Seems the side facing the cars is the intake. Okay, there we go. We got a little heat up there. Let's go down a little bit. It's not too much. As comparison to about 100, almost 100 on the other car. It is something. And got to do a quick recalibration. That is actually from the sun heating up the concrete. Let's try and get in a little closer. 90. So far it's keeping pretty cool. Even the cable. Now this cable is in bright sunshine. Now it's getting warm right where it meets the car, which is the usual spot. And just remember, this is nice sunny California sunshine. You can see the side of the cable getting the sun. If we go up here, it's not in the sun. I think it might even be, I doubt it, but it might even be refrigerated. I'd love to see inside one of these. But that is still pretty cool. Let's go back to this one. This one's at 85. Sorry, did you just plug in?
Probably about 10 minutes ago.
You mind if I do a thermal?
No, go ahead.
These are the new liquid-cooled superchargers. And it's slightly warm, but it's pretty much the same as ambient. I'm very impressed so far. The heat output's pretty low. The heat buildup is low, I should say. Oh, there, it's kicking out over here now. Still only at 83. Either way, their new cables seem to be promising. Smile, cheese.
In other news, and I think I can talk about this, is that Honda has, it now appears that Honda has come 180, according to this article, and that They are officially embracing electricity, and they are. The new vision for the company is that they will evolve and use electricity as its core technology. They
For playing the radio or what?
You know, sure, right? No, actually, they're moving into what they're doing is getting rid of what they call anemic hybrid Accord, but moving into another hybrid and fully electric car that they expect to come out in 2017. 2017. Yeah.
Okay. Honda used to be so dominant, and they are so lost.
Yeah,
now.
pretty much.
But the 2001 through 2003 Honda hybrid, what was it called? Insight.
Oh yeah.
It's like a cult car. These guys drive them till they have 350,000 miles on them, and then immediately go out and buy a cherry, almost new one with like 150,000 on it, and drive that one 250,000 miles. Huh. And they're like serial Honda Insight owners.
Yeah.
And I mean, it's kind of a funky looking little car. It's very light, aerodynamic, 2-seater, plenty of room in back. It would make a good conversion candidate, but they're kind of pricey to pick up because the guys are still driving them as hybrids.
Right.
And you don't want a car with 400,000 miles on it to start with as a donor car,
right.
So we're kind of shut out of them. But, 20, 30 years ago, Honda and the Accord was just like the #1 car in America.
And
most stolen car. How lost, dazed, and confused they've been recently has kind of caught me. I've been astounded.
Yeah, for being so dominant, right?
Right.
And so they're.
And then they had a later Insight that was just a dog. Nobody liked it, and now they've just canceled their Fit, their electric and their hybrids.
Yeah, interesting, right?
So that they're
for
going
him
to
to say
out
this,
with
and
right. That's.
Right. And it also says this, of course, doesn't mean the end of the much-loved, in Japan at least, their fuel cell vehicle. I guess
the
that's
Honda fuel cell.
Like that going on.
Yeah, be still my heart.
Yeah. And that's pretty much it on that. Kia has ramped up the Soul EV infrastructure. They are going to start selling them in Washington and Oregon. They have 20 new dealerships, or I should say 20 of their dealers, if they aren't already there.
Are adding the EV.
Right. 12 in Washington, 8 in Oregon. They are increasing their fast charger network with 10 new chargers, which will be at various...
Chatamo again.
Yeah, which will be at various 10 of those dealerships. And each of the dealerships has 2 level 2 chargers. Okay. And the Soul EV owners can charge for free at the dealership.
The Soul EV owners?
Yes.
Other owners need not apply?
Need not apply.
Okay.
Yeah. Maybe for a fee.
Well, that's very generous.
Yeah. And just for little specs on the Soul EV, it has an EPA estimated range of 93 miles. It has a 27 kilowatt-hour battery, 360 volts. Which interesting, their battery feature, it's a nickel, cobalt, manganese with a graphite-based anode. And the cell, additionally, the cells use a gel electrolyte, and each cell contains ceramic separators. Is this?
Yeah, they kind of describe it like a lithium polymer battery, but I'm not too sure what they got going on there.
But more of an NMC.
Yes.
Yep. That is pretty much that on them. Volkswagen has come out with a smaller single cell, if you will, battery. I guess they had their pack was broken up into 2 packs, and now it's in 1. And we should have a picture of that to go up as well. Okay. Which they expect to help to reduce the cost of the vehicle. And they, where did I have this? Here it is. This battery, VW is researching a super battery in Silicon Valley that is cheaper, smaller, and more powerful. an electric Volkswagen that can travel 186 miles. That's the NEDC standard or measurement, where the EPA rates it at 125 miles. In addition, they have will have a 3-wheeled semi-scooter called the Last Mile Surfer, which is kind of a rival to the Segway. And so you can evidently carry that in your trunk, park X distance away from your destination, and ride the scooter the last mile.
I'd be satisfied just if they'd come out with a good electric car.
Yeah.
Now, you like the e-Golf.
I do.
And that's kind of been a compliance car, but if they would start selling that more widely, I think it might have legs.
Yeah, yeah.
So is that the news?
That is the news.
Well, we do have a few videos that have come in across the transom. Not many, but some. One of them I was particularly glad to hear about was Nick Smith in New Zealand. Nick has actually been he was the keynote speaker at one of our EvCons.
Great guy.
I was kind of considering not having it, and he said that I had to have it, and so he got named keynote speaker. And I said, well, you and I will have it, and you can be the keynote speaker.
Yeah, I'll Nick is
take
actually
the second slot, and then between the two of us, we got a show, and I'll buy the beer.
Yeah, and
it turned out a lot of other people came too. And I think it's going to go the same way this year.
Yeah, I sure hope so. We've been, that's kind of one of the things that I've been busy with this week. And Nick is actually responsible for the EvCon 2015 Facebook page. So thank you, Nick.
Yeah. Well, good. He was the first one to sign up for the first EvCon.
And he signed up last year before he left, in fact, so he's...
Is he the first one?
He's probably the first one this year as well.
And but he's been a big supporter. He and Steve West are going to be speaking, and I think presenting on their New Zealand network of fast chargers, using Charger from Tritium in Australia, who I tried to find out about getting for us here, and they've already done some sort of exclusive deal with ChargePoint. Every time I've dealt with this company in Australia, it's wound up being, it doesn't work.
Oh, really?
Yeah. They don't have it yet, or they did have it and don't have it now, or they've got something.
Stay tuned. We'll get back to you.
They have some great technical ideas and developed some very interesting products going back 4 or 5 years. And as a business, jeez, these guys are lost, dazed, and confused permanently. And but Steve West is buying some stuff from him, and he does know how to run a business. And he's putting these in New Zealand. So Nick and Steve will be with us, regaling us with tales of the New Zealand network, I would imagine, and perhaps some other things. But Nick went through a divorce and some other changes, and he's got this Miata that he was like converting beyond from scratch. I think he cast his own motor adapter out of Mountain Dew cans or something.
Is that right?
And melted them and actually cast the adapter himself. This week, he takes on the instrument cluster, and I was astounded. Let's take a look.
Okay.
So while the car's in storage, I've been playing around with the instrument cluster, trying to get my dash gauges to work as per the original car. And I've purchased this second-hand dash gauge, and I've been hacking it around a bit and getting the temperature, fuel, and the missing oil pressure gauge to work are pretty basic PWMs. We're driving those from the SparkFun MOSFET board there, and an Arduino Uno doing the processing. Getting the tack to work was a little bit more complicated, but as it turns out, the NB Miata is pretty much the same as the NA Miata, even though the drivers for the gauges themselves are a little different. So to get that to work, we had to put in an inducting coil, which I've taken out of a relay. I've hooked the relay contacts out of that, otherwise it makes a really interesting sound when you're driving it at 20 or 30 hertz and ramping it up. So the circuit diagram for that is there, and the 5 volt square wave obviously coming out of the Arduino into the MOSFET. Excuse me if that symbol is not entirely correct, but doesn't really make much difference to me. So the 12 volt supply straight from a computer power supply, and that actually plugs straight into this SparkFun MOSFET board, which is quite cool. That by default gives you the 12 volts and the 5 volts, but if you wire it up differently, the 3 MOSFETs on the left hand side can be 12 volt drivers as well. So I'm not going to bother showing you the fuel and temperature gauges, etc., but if we just turn on the board here, we can see the Arduino is driving the gauge up and down. At the moment I'm just using the basic tone command out of Arduino and running that between 30 hertz, which is its minimum, and approximately 265 hertz to get to 8000 RPM. So you'll notice it does a little kick here and there, and I'm not 100% certain why that occurs. Some cleverer people out there than me will no doubt have some ideas, but I'm going to carry on with the programming, and I'm going to try driving the frequency directly rather than relying on an inbuilt function. So we'll see if we can A, smooth that sweep out, and B, get any frequency under 30 hertz, which will be the 0 to 1000 RPM on the gauge. So stay with me. So running the whole dash cluster here, we got the Arduino Uno and the Seed Studios CAN bus shield. Stack us up on top of there, and then on top of that we have the SparkFun MOSFET board. So long-time EVTV viewers might recognize this. Looks very, very familiar, and in fact it's all the same components that I forget the guy's name, but the guy up there in Michigan or whatever put together for Jack. Anyway, my programming is obviously a lot more simple. It only has one job to do in my car. It doesn't have to be repurposed into other people's cars. So like I said, very, very cut down code. So we've got the CAN bus connection here and a little twisted pair, and another Deutsch connector going off to the HP EVS harness. This rather dodgy looking bit of wiring here goes to a speaker, and that's a little bit temporary at the moment, but that speaker will activate and warn me of a ground fault detection error. So I may be able to make it notify me of a few other bits and pieces as well quite easily. So there we go. Just 6 channels out of the MOSFET board. I need one for the temperature gauge, one for the inverter temperature gauge, one for the fuel gauge. Taco will be running directly from pin 2 output on the inverter. Another output for the speaker, and 2 more spares for Not quite sure what just yet. I do have an eco button on the dash, so one of them may turn that on as well. And of course the low charge or battery warning light, so that adds up to 6, so we'll see how we get on. So another part of the whole conversion process, I decided it might be nice to do some custom gauges. So here is basically what was my existing dash cluster, and actually what it is my original gauge faces put on a spare cluster I've been hacking about. And I contacted a guy called Adam at Rev Limiter, and what he's done is he's designed me a nice set of custom gauges, these replaceable faces. So he's sent me a nice little set of these gauge faces. So there's a new tacho, a speedometer, and gauges for motor temperature, state of charge, and inverter temperature I've decided as well, and well, basically an on-off switch or an indicator to tell me the state of the vehicle. Turns out that particular one is too opaque to let the 3-color LED shine through, which is a 12-volt 3-color, so it's red, green, orange, and that fits nicely into the little socket left here by what was an unused socket on my dash cluster, but I've modified this to just fit that in, and it drops in there quite nicely. If I can, yeah, there we go. So that just pushes in there, and once I push the decal into place over the top of that, that'll hold that in nicely. I'm currently laminating up a new clear version of the on switch, so I've got some versions I did here. I've got 4 sets of each, so I'm going to laminate that up. That's just drying at the moment, so I'll see which one looks nicest in the cluster and fills in the holes best. But so that's my old mock-up thing I'm playing with, and I have the real one right here. And eagle-eyed MX-5 or Miata owners would notice that I've moved the fuel gauge from its original position, which was here, up to the middle center, which I think that's probably the most important gauge on an EV personally. So also what I've done here is I've incorporated a light for the eco button or the eco indicator from the Curtis controllers, and the on-off indicator go up there again. Once I get that in the car, I'll be able to put the needles on and set everything into its correct position, but in the meantime I think that's looking pretty fantastic. I sourced some new LED cluster lighting, and I got some colored ones for the high beam and the eco and the ABS lights, so they look amazing. But the lighting, just at night, this thing lights up gorgeous. It's absolutely beautiful. So I hope to bring you some images of that before too long. And when that all gets buttoned up and snapped down, we'll have the cluster face over the top, sort of hiding everything, dressing everything up. So I think that's going to come together beautiful. So we'll carry on. So I've carried on, and I've got my new homemade on-off button decal made here. This is 2 layers of overhead transparency film printed on the front layer. I've got 2 layers of Scotch tape stuck on the back, which makes it a little bit opaque, intending to diffuse the light through it. And then another layer of OHP film laminated on the back. So that's going to go over the 3-color LED, which I've sort of put in place here. I'm going to put a couple of black O-rings in the front, and this will trap everything together once the front decal goes on and presses down on these pins here. Something I didn't mention earlier was that the gauges in the car, initially this is the fuel gauge, this was an oil pressure gauge, and this was a temperature gauge, as it still will be. They're basically the same construction, but all 3 gauges operate differently. So what I've had to do, I've dismantled the backing, and I've taken the whole coil driver of the fuel gauge and reassembled it onto the back of what was the oil gauge decal up the top here. Then from the spare dash cluster that I showed you before, I've actually taken a second temperature gauge mechanism and put it on the back of this thing here. So these 2 temperature gauges work correctly as temperature gauges, and this one works correctly as a fuel gauge, i.e. extremely slowly reacting to any changes, which is good. I mean, we're not going to draw down 16 amp hours of battery inside of 2 minutes. So this gauge up the top here is intended to be run eventually off a JLD 505, which I may pick up at EVCON this year, I hope. So that's my plans. The car still does have a JLD 404, but long term what I'd like to do is to make the fuel gauge up here the primary indicator, and talk to some clever people about maybe interfacing the CAN bus information into a display on an Android head unit stereo or something. At the moment the car does not have a stereo, and it would be quite nice to have the tunes in an open top car. The CAN bus, I'm expecting to be able to put messaging from the 505 onto the HP EVS CAN bus, which I'll be picking up on my Arduino Uno and CAN bus board, and that with the relay drivers and everything, that will operate all of these gauges and all of the indicator lights, etc. And of course the fuel gauge sweep. So that that CAN bus might also be able to be routed towards an Android head unit somehow. So if anybody's got any cool ideas on that, it's definitely a stage 2 project, but something I'd like to start thinking about if anybody's got any ideas. So I've installed my little button. It's all held in there with some O-rings and trapped behind the front fascia bezel. And so let's see how it works. We'll start off with the red. That will indicate a failure condition, like gas cap open. And then it goes to orange, which means all good to go, ready for start signal. And when the engine is on, or sorry, motor is on, we go to a green. Now this complies with the New Zealand rules for our builds, which tells us we need an indicator to tell us when the vehicle is on, and that should do nicely.
So that's Nick with the Miata instrument cluster, and I have to say that this is almost an advanced topic. This is the kind of level of effort that I always think you can't hardly do for one car. Now, here's the rub. He's doing it for this one car. except Miatas are very popular.
Yep, there's a few of you guys out there, right?
And so I could see if I was going to do a Miata, I'd just
call up Nick and say, "How'd you do that?
Can you make me one of those?"
Yeah.
No, not how do I do it.
Can you make? Yeah. What's it going to take to send me one?
Yeah. What would the number be for one to show up here in the States next to my Miata? And but the level of effort he's going to on this to completely redo the original instrument cluster. It's astounding. It'll look like a Miata cluster, except the gauges are a little different and they work a little differently.
They speak electric.
And, and he's using actually a motor driver, spark fun, little motor MOSFETs, shield, to drive some of it.
Yeah.
And I was a little vague on the tachometer. He had a little diagram there, but a MOSFET with an inductor and something he was doing to drive the tach. But it was past my pay grade.
They are basically stepper motors, aren't they? The gauges, yeah.
Well, it varies the gauge. Most of them were pulse width modulated signals, but the tach was a little different. It was like a pulse counter, and you actually have to generate the frequency that you want to simulate pulses.
Yep.
And so, but an interesting take on it. Let's go take a look at Colin Kidder. He and his father are working on the SL190 Mercedes, which again, that would be my dream car.
That's a gorgeous.
But man, they're a lot of money. Anyway, Colin's doing some interesting work on the SL190 to extend both the inputs and the outputs to our generalized electric vehicle control unit. Let's take a look.
Hello EVTV, I'd like to update you on the 190 SL project and some of the software work that I've been doing. The 190 project has actually gone fairly slowly. You've probably realized we don't have a whole lot of status updates all the time. Kind of gotten busy. It's a project we're doing for a customer, but it's kind of been on the back burner as we do other stuff at work, so that's kind of been dragging out. We have 99 of 100 cells pretty much mounted right now. I have 96 mounted and 3 about to be mounted. There's various video of that I'll show you in a moment. So we have just about one more cell left. I've been doing a lot of software work to get JevQ up to running in this car. We have most all of the major hardware mounted. We're still looking to mount coolant hoses. The radiator is in place. We pretty much know where the pump is going to go. So we're looking to get this thing rolling next week. So I think next week we'll have a status update where we actually have it rolling, even if it's hacked together with baling wire and tinfoil. So after that it'll probably look a little nicer, but our goal is to get things working next week. Stuff that we're doing, let's see what notes. I'll have a video. I found 2 pieces of hardware that are fairly new. One is called a Keybox, which is a 12 relay CAN bus controlled I/O module. I found that all the things that I want to add to this 190 went over the 8 outputs that the JevQ could do. I have one of the problems with the 1950s car is there was no electrical anything, so to add anything at all I have to have my own hardware inputs and outputs for absolutely everything. So I went over the 8. I have a lot of things that I want to do, run dash gauges, the PWM control to the coolant pump and things like that, and it just wasn't going to fly with just 8 inputs or 8 outputs. So I've got this 12 relay key box that I can use to have a lot more outputs. I'll have 20 outputs that way. What I'm doing right now, the key box runs on CAN Open, which is a little higher level protocol than standard CAN. And what I'm doing now is adding to JevQ a virtual I/O type system where CAN bus connected modules like the key box can extend the outputs. Right now the outputs in JevQ are 0 through 7 for the digital outputs, but what will happen is when the key box initializes, the system will make it 8 through 19. So if you set, say, your pre-charge to output 14, the code underlying this will say, well, that output is on the key box. Instead of trying to directly digitally trigger the output, it will send a CAN bus message over CAN Open to the key box, and that will allow us to have some more digital outputs. I also have a PowerKey Pro that I'm going to show you. It's a 12-key keypad that is also run over CAN Open. It runs a lot of functions that the car didn't have. I'm actually going to add cruise control to the car by running a brake input to the JevQ and having cruise control buttons on the 12-key pads so that you can actually set cruise, even though this is a 1950s car and they didn't have cruise back then. So that'll be kind of interesting. The keypad, the PowerKey Pro, I'll show a picture of it here in a second. It's a pretty sharp looking thing. We're mounting it on the dash where the driver can get access to it properly, and it will be able to give us a lot of feedback and provide functionality that I kind of needed. The JevQ would ordinarily only have 4 digital inputs, so I couldn't have very many buttons that way. The same type of scheme is being implemented in JevQ for this, where the inputs will be virtualized type of inputs that run. So the current inputs are 0 through 3, but this will be 4 through 15, I believe. So it will make it so that in the JevQ web page you can set larger numbers of digital I/O than you previously could. What else did I want to say? Oh, I'll try to show a picture. I'm mounting the accelerator pedal. I actually did buy a Tesla accelerator to put in this car, just kind of on a lark, because we needed an accelerator pedal, and the Tesla pedal is a dual Hall effect pedal, so that's kind of nice. I'm mounting up some of the other contactors and things. Hopefully I'll get a little better video next week on that, but in the meantime I'll show you some videos here, both of the the key box, the PowerKey Pro, and some of the video that we have shot for this project so far that we haven't shown you yet. So thank you for watching. Alright, here are some of the components we're going to put in that car. This is a Blink key box. It's basically just 12 relays in here, controlled by CAN bus. The relays all connect 2 wires together, so we've got, I think this is 30 wires. And each relay connects 2 wires together, so you're pretty configurable what you want to do with it. You can connect 12 volts to things, ground, connect any signals you want, CAN bus wires here, and then power, and that's all there is to it. So that's a pretty simple to use little box here that I can use to extend digital output in this car to have 12 extra outputs that are configurable. I've also got over here is a PowerKey Pro. This is the 2600 model. I've got most of the insignias on here. What we're going to use this for in the car is control various functions. Turtle here will be eco mode. Rabbit will be high performance mode. Both of these are forward. And then this little park icon for neutral / park type position where the motor controller is not running. The company I ordered this from did not have a reverse decal, so that has no decal just yet, but that will be reverse. Then, since this is a 1950s Mercedes, cruise control was still probably decades off. So I have cruise control added here. Set and decelerate and accelerate for cruise control we'll have on here. 1, 2, and this was going to be an off. These are the regen settings. So this would be low regen, high regen, and regen off. Sometimes cars put regen as dual purpose on eco and performance, but I'm not going to do that. So this would be controlling how fast your acceleration is allowed to be, and this will control how much regen. Then we have a fan button here, which we'll use to be able to turn on the coolant fan manually if anybody wants to do that. I have here the emergency light hazard flashers, because once again in the 1950s I don't think anybody had emergency flashers, so that's an addition to the car. And in the 12th position here, I really don't have any use for it just yet. This is probably going to be a general car status. All of these buttons, all 12, have what's essentially tricolor LEDs. So they're green, red, or green and red together for kind of an amber yellowish color. So they can all light up 3 colors. I'll probably have this be system state, so if this is green, you have the system's fine. If it's yellow, there's a warning. If it's red, there's a fault. In all 3 colors, you can have flashing, so green will probably always be solid, and that will be system okay. Yellow solid might be a warning. Yellow flashing could be, say, a more serious warning, and red is a fault, with red flashing being a serious fault. So this is a pretty handy thing. It's like the key box where everything's on CAN bus, so I'll have to spin these together for twisted pair, but those are the CAN bus wires and power wires. So you can get 12 buttons with just 4 wires. So we're figuring that'll be pretty handy. Next week we'll have this mounted on the dash. Actually, next week we should have the car rolling. So then we'll have more footage of the car actually operating with all this functionality, and should be good to go.
Back here for an update. I believe we showed this battery pack. I just finished building this one. It's kind of difficult to see for the simple fact that everything's black. We had to dodge around the lever for the emergency brake. Missed this. Batteries have to sit in here. They sit at a slight angle. Had to take it all, the other one down, custom, cut it all apart. I welded nearly an inch thick of aluminum block here, drilled and tapped it for the hold down. Everything's been cut down, re-welded, repainted. It ties into the frame over there, ties into the frame around the hold down here. It's got a screw right down through there. A screw here, a screw back here. This will be where the tie down or the hold down goes. So there's room for 2 here. Colin's got a lot of the other wiring done, and I'm gonna put these batteries in here. Then he's gonna have to wire them because I need to put another set on top. So he's ready to get rolling with that. Everything clears. We're running the hose. I'm gonna run out here and get a 3/4 T. We got a tee off and go into our reservoir. And the reservoir, we'll use it as an expansion tank. We'll keep it about half full. And as the liquid heats up, it'll expand up inside higher. And as everything cools off, it'll pull back out and get lower. We're putting in a new water pump made for this, higher volume, larger diameter than what we did before, because we didn't have as much volume of water before. So that'll be here. The water will go back. The water line will actually come out of here. It has to go into here. So we may have to move this water pump up in here. We're not sure yet. May mount it right here. This line will come down into it. Possibly tee off of that and go into the tank. I gotta kind of look that over. This is the inlet. Goes through here. Outlet, I got to get a 90. We're going to come out of here and turn this way. It'll be sticking out, turning this way. It'll come out here, swing around, go under, and go down into the motor here, either front or the back. Then it'll come back out, come back around, and tie into here. We'll have that wired up hopefully later today, or piped, I should say. So I got to go get a 90 and I got to get a 3/4 T. Everything else it appears we have here and all hooked up. This is the top that I had to make. That'll go on top of the batteries and it'll hold them down. Then Colin can wire it and then I'll build the next one above it. So progressing. We were hoping to drive this car by the end of this week, so I got to hustle. It's Wednesday. Okay, a couple more hours into it. I have the batteries placed in the mount. Drilled and tapped this. Got a nice 3/8 bolt here with a nice cover. It is very, very strong in. Got the other side tensioned in place. One small thing we just discovered. We took measurements before, but the hood has a reinforcement all the way down and across the front. And we tried a different hood just to make sure. It's rubbing right there on this edge, and I really have no room to move over. We're going to modify the hood just a 1/4 inch of a cutout or a bump in right here on the hood, on the painted hood, so that it clears this, because it's just, we tried a extra spare hood we have around, and it rubs right there. I put this on and rubbed it back and forth to make sure it was bumping. It's just barely touching right there. So we'll take Harry's hood and just come in here and put a small round out in that reinforcement to clear that battery tray. Because I really can't alter the mounting of this and still be in line here without taking and re-drilling everything out here and moving this over. And this is very close to here. It's mounted in rubber. We can't have it rubbing. It's nearly touching that screw right there. So I can't come 1/4 inch over, letting me move this 1/4 inch over. So we're going to just modify the hood right here. Everything else clears, sets in here properly, looks great. So not something I wanted to do, but an inevitable issue that we can overcome. Now I'm going to work at another battery tray sitting up in here. Meanwhile, Colin has already started to wire the battery pack up here. He'll be jumping off of that, coming down to here. He'll be jumping off of this one, coming up to the battery packs I'm going to put in here, and then he'll jump off of that straight down and power this. So the cables will probably have to come in here, wrap and come in here, wrap and come in. I did not get a chance to get a T yet. I'm going to get a T. We're going to, before we put the rest of the batteries in, we're going to wire the, or put in the heavy-duty 3/4 inch water hose. We're going to route that and get them where we want them so we have clearance for that before I get the rest of the batteries. I have 4 more batteries to go. This is July 1st, 2015. We're coming along slower than I would have liked, but we've had an awful lot of business, which is good, but it has slowed me down on this project. So we're gonna put see, I've got 1 2 3 4 5 6. I got 4 more batteries to go because I need 10 under the hood, and we'll tackle that tomorrow. Hopefully I'm gonna try and get this done tomorrow so we can bat the car around early next week. Thursday, July 2nd. All the batteries that I have put in are wired. I just now am finishing this battery mount. Three more will go here. The battery pack underneath, Colin has wired already, and it comes up and terminates here. Now we'll jump off of a corner there over to these, and they'll continue across. We've got them nicely mounted here to this frame. They fit snugly, but they do fit. I utilized one of the old areas and cut up the old bracket, welded it down. This corner has no support yet. Temporarily, we're going to be just fine. Like I said, the batteries fit kind of snug. I got to work them down in there. Sometimes these screws stick out just a touch farther than they should, and they rub on each other. So I know it looks funny now, but they do go in there. I just had them. I just had them fitting. But anyway, that all has to come back apart. I got to build the hold down for the top. These had to be put, these are 1x1 aluminum. They had to be put in the mill and cut down to 3/8. Or they'll lay against here and short out all the batteries. So these have to go on here on top with some end pieces coming around here. I'll most likely weld angled piece of aluminum here, threaded, so we can come right straight down through with a bolt. I'll put a little bridge coming up off of here, maybe this high, and across and down with a 1/2 inch thick, probably a piece of this material right here, drilled and tapped. That'll set inside of here, and there'll be an ear up here with a bolt coming down into that. The other side, I can do something similar. I left the flap out here. I will weld a small 1/2 inch block here, drill straight through and tap it all the way, and then have a bracket come down here maybe a little bit, and then a bolt coming down and threaded right straight in, so it'll hold these down in place. And I don't know why that's giving me trouble fitting, but I can't do it with one hand while I'm holding the camera. So anyway, the next thing would be to fit these around it, measure, tack them in place, and then build the tie downs. And then, because there's 3 up here on top, we're down to only needing a place for one last battery. And I might piggyback it right in here. I'm trying to leave myself some room down in here for the water pump and some fittings and things like that. I still have to run water lines. I need to pick up a T, which I haven't done yet. So when this comes out to get painted, we'll finish the water lines, mount this back in here once the water lines are done, finish the mount for the last battery, wire it up. We're actually, at that point, ready for a test drive. The hood won't be on. As I mentioned, the hood rubs right there, but I can't help that. We're tight for space here, and I couldn't move everything over. So we'll either modify that corner a little bit or modify the hood or both. So we don't want it rubbing, but I think we can round this corner here and grind or dent in or grind out the hood just tight slightly. We have to be really careful, but the hood does rub right on that shiny point right there. So we may try to just grind some of this down. It'll still support the corner. We may bevel that and round it and see if we can get the hood not rub. I'd rather not adjust the hood if we can help it. So, but we're coming along nicely. Be here about a half a day tomorrow on the 3rd. I'll see if I can't button this thing up. July 2nd, 6:15 p.m. Just got in trouble because I'm not home yet. Supposedly we're going out to eat and they haven't been able to get a hold of me. Tacked a bracket together on top. I cut up and utilized some of the old battery hold downs. We'll come through here, I'll weld a plate up down here and drill and tap it, and we'll just run a bolt through that down in the plate and it'll pull down on here. The other end isn't together yet, but I'm out of time. Got 45 minutes to get cleaned up and get over to a restaurant. So I'll build a end here, build a little mount here, drill and tap. We'll put large bolts down through. We have even those left over from the other battery hold down. I held on to everything. These are stainless steel bolts that shouldn't corrode going into aluminum. So tomorrow's July 3rd. Be here about a half a day, hopefully get some more work done, get these batteries all mounted in. Okay, I pulled the battery box out. It may look like a weird contraption, but we'll drill a hole here, drill and tap a hole here, run a stainless steel threaded rod or bolt through to pull the batteries together. The box already fits. I welded another thick block on here that we can drill and tap. We'll either use that hole or move over here, drill another hole, come down through, drill and tap, bolt it down, it'll pull this down. 2 mounts here. There's a third mount here I'm thinking about doing to stabilize it to the other one, but I want to get everything in first. I can add that afterwards. But this is finished, just needs to be installed. 2 holes drilled and tapped and installed, and then we'll find a home in here for that last battery and we're ready to move. Well, guess I got to hook up the water yet, which I'm going to do before I install this next battery pack. So it is 3:15 in the afternoon, July 3rd, 2015. Everybody's abandoned me. So we got some plans for later tonight, so I'm going to take off and get cleaned up. Get back on this Monday and hopefully be driving it by Tuesday. A few electronic things to do. This is wired. New fuse box assembly is in. This has to be tucked back in. I think accelerator cable has to be finished being hooked up. My son will be doing that while I'm putting the battery packs back in. So get some shots on Monday.
Interesting thing there, on the dad's side, man, was he being beaten by 1/32 of an inch. Uh-oh. And that happens to me a lot. Uh-oh. Sorry, Mr. Kidder, that's part of the game. Yeah. He had a corner of the hood just touching the battery.
Battling that too with the EVIC and the thing.
Yes, you're cutting it pretty close with the EVIC on the green thing.
Yeah, stay tuned on that. We haven't seen or shown much of that, but hopefully we come out victorious.
A little more EVIC display than we quite have dashboard there on the green thing. But, but you're getting it pretty close. Well, he's going to put a few dings in the reinforcement of the hood and get that to fit. They're not doing that car to suit me. I have to tell you, every design choice they've made has been exactly not the one I would have done.
Well, hopefully at the end of the day,
I was very
nice
taken
car.
with Colin's work. That Power Key Pro 2400. This is a bank, 2 banks of 6 switches that you, it's a little bit more than he even quite describes. You can make any of these switches put out any CAN message you want. And then you can also, they have LEDs behind these lenses that are RGB type LEDs where you can make it come on red or green or amber. And you can do that by CAN. That's not you press the switch and it comes on. You press the switch, it sends a CAN message. Now you can send the CAN message back and change the color of the switch.
Right.
Or turn it from off to on.
Could be handy.
I have contacted these people. I'd like to carry them in the store, and they simply won't talk to me. So I'd like you to contact them and see if you can do any good with them. But here's the problem. This would be a great product for our viewers.
Okay.
Except for one thing. And talk to them. How do they handle this? They've got like 200 little things that go on the switches that have, you know, like a rabbit or a turtle or a clock face or a lightning bolt or a, you know, a little graphic.
Label,
Not like labels, they're like, you can see through them.
Okay.
They're etched out to where the light shine through them.
Okay, got it.
In like 200 different graphics. Now, how would we stock that, and how would we, you know, our viewers be able to select that, what they wanted? And they didn't have a P for park.
Huh.
You know, I mean, that sort of thing. It's kind of an odd product.
I'll have to check it out.
But it's a great idea. If we can't get them to do it, maybe I'll just take some switches in an Arduino and make one of these things.
Sounds doable.
To where you have a switch box that you press a button and it puts out a CAN message. Any CAN message you want. So Colin will be able to add switches as inputs to the JevQ on the second CAN bus.
Okay.
And he also has a relay board that he can control by CAN to add additional outputs.
Oh.
So he can add 12 inputs and 12 outputs to, we already have 8 inputs and 8 outputs. And for a total of 20 if you need to expand of our JevQ unit. So it's kind of cool.
Yeah, that's a lot.
Hopefully by next week they will actually be rolling in the SL190. I had a Rich Morris, of course, was last week, told me that he would turn it on 6 or 8 times and it wouldn't come on, and then it would finally come on, and that there was something wrong with the JevQ. So I spent some time this week setting up our latest JevQ version and the UQM bench, which had simply fallen into some disarray. I was using the battery off of it to do all that volt and Delphi DC to DC converter, volt to APM,
so now left it on and
all that. And so you know, I was using that battery, but we haven't had the UQM on in months. So I got it back together and got it fired up, and it worked fine. Turned out Rich was having problems with one of his contactors.
Yeah.
And he got that straightened out. I think just a connection to it. And so it's rolling pretty good now. But he'll have, as I told him, 6 months of, you know, it's kind of like, it feels like it never ends You got to get your heater, and you got to get some air conditioning, and you got to get the radio working, and the DC to DC converter, and the
kind of what I'm about to face
left
with
signal
the thing.
and the right signal. You might as well put in LED bulbs in the thing, but then the turn signal blinks too fast. Unless you put a resistor in, which makes no sense because that then eats up the current that the LED now doesn't.
Yeah. Kind of defeats the purpose of the LED, right?
So you flail with it. And then, of course, as many of our viewers can tell you, without the roar of the Ford Big Block V8 to mask it, all of a sudden, every spring in the seat squeaks.
Yeah, right.
The hubcaps make a terrific racket. The shock absorbers never do shut up.
You hear
every noise in the vehicle. And so all those have to be tracked down. And then, so it's, as I describe it, doing an electric car conversion is not the big deal most people think. It's a series issue of small problem solving. It's just like being nibbled to death by ducks. 300 little problems.
Sure.
And if you work them each off in order, it's
partly why we do it.
One day and you got a good car going.
Yeah.
And then all of a sudden one day you go out and your car doesn't need you anymore. It's kind of
done.
A melancholy moment. It's sort of like when your kids go off to college. You wanted them to go to college. You wanted them to go off to go to college.
Yeah.
And you did want them out of the house.
And now?
And they went this weekend. And now the house is kind of empty.
Quiet. And the car is now reliable. And
you thought that would be a big relief, but it's just kind of feels like you're haunting the place. And it takes a little adjustment. The cure for the post-partum blues on the electric car is to get started on the next conversion.
Yeah, I'm going to say that too.
And so
there's plenty to do out there.
Speaking of which, we've been working on the Tesla thing. There's not a problem. In fact, it's going quite well. We're kind of spending more time working on the tools than we are on the Tesla.
Right.
And it seems like we're doing an awful lot of getting ready. But we continue with the work on SavvyCAN and on the Jevret box that goes with it. And likewise, on my little one-off version of the JLD 505, I'm doing to inject sensor data.
Right.
Ran into a bit of a problem with the temperature sensors, the Dallas One Wire.
Yeah.
For some reason, when we start getting traffic from the car that we're simulating, it just locks up if we're checking for temperatures.
Yep.
I just don't get it.
That was quite the frustration.
I have had a number of people correct me on the inverter that it is liquid cooled, and I guess I'm kind of convinced at this point that they're right. The can that goes over it really isn't part of the inverter.
No, it's just a
it
can,
just
a cover.
Encloses it and doesn't really touch it.
Yeah.
And so it's not used as a heat sink, so the temperature we're reading really isn't related to inverter temperature.
That's right.
But guess what is the heat sink?
What? The bus?
The gear drive.
Yeah. Oh,
case.
That's right. Yeah. That's why it gets so hot.
And that's why the gear drive was getting so warm.
Yeah.
And that's actually the heat sink base for the inverter is the case of the gear drive.
Yep.
And so that seems to be the case. But it appears that the inverter is liquid cooled with the motor, which I think is kind of a dubious thing. You wind up with the motor heating the inverter more likely than anything else. But they do have liquid cooling and pretty big thermal mass in their gearbox involved.
And the oil in it.
And the oil in it, I guess so. Yeah, I guess that's right. And so that seems to work. But we're working on the tools and the setup. We're going to, for example, replace the throttle, now that we know how it works,
Yeah.
with a 2-gang pot potentiometer, where one of them will put out half the voltage of the other.
Yeah. And we can set it to whatever RPM.
And then, you know, I'm used to our test benches. I have a dial that I can vary.
Run it up or down. Or,
with a great deal of resolution and gradient, dial in exactly what I want for throttle.
Yeah.
To observe things and kind of finally balance them where they're maintaining a specific RPM and so forth.
Yeah.
So we're going to add that to the bench. And so that's kind of where we're going with it. But I can't just have week after week of video about the Tesla CAN bus.
Watch it a motor spin or, you know.
Thing. It's
couple guys on
we'll have to have
laptops,
some,
you know.
some further developments. So Bob here has kind of picked up the slack and spent a good bit of time this week with the green pickle thing.
Yeah.
And let's go see what we got going there.
Well, let's go.
As our world grows, it's necessary to invest in sustainable transportation to reduce our impact on the planet and ultimately create economic efficiencies wherever possible. Electric vehicles are becoming the leaders of this efficient, sustainable movement. In electric vehicles, the driver experience is just as important as the batteries that power it. EVs display different information than conventional vehicles, such as the amount of energy stored, expected mileage on a current charge, and distance until empty. Monitoring vehicle efficiency and energy consumption are more critical than ever because of driving range limitations experienced in EVs that are different than your conventional vehicles. This presents new challenges to structure and simplify new driver information for operating EVs. Andromeda Interface's EVIC was designed to collect, interpret, and consolidate data onto one vehicle dashboard to provide a reliable and configurable device to monitor the operation and safety of your electric vehicle. From monitoring your motor controllers to your battery management systems, EVIC is a human-machine interface that seamlessly interprets all the complex data coming from these devices. EVIC presents the driver information in one simple display unit, and we are continuing to build our portfolio of certified interfaces from other EV suppliers. Please review our list of supported EV components on our website. Andromeda Interfaces is striving to enable human-machine technology that helps improve the safety and efficiency of electric vehicles. By doing this in a cost-effective way, we are helping to accelerate the growth of sustainable transportation.
Okay, when last we spoke, we were going to start talking about green things some more.
We're getting more activity on it.
The pickle. What have we done?
We have got the Brusa all wired up and charging.
Okay, so you got the 2 square plugs wired up.
Yep.
And we've got kind of an interesting situation with a junction box.
Yes, where we've got the J1772 from the front.
This
combined.
is the first time we've used the actually the cable sets from Azure Dynamics. I sold quite a few of them, never quite used any.
Hope they're working out for you guys.
But we have a technique that I know is kind of backward for today when we're talking about Chatamo and where J1772 is old hat. And that's what I like to call NEMA 5-15. And my good buddy and one of the great guys at documenting electric vehicles as well as building them. He makes some beautiful builds. He did a Speedster, and then he did a Saab Sonic, a 60s version Saab Sonic.
I don't even know what that is.
Well, it's none of them were ever as good as what he built. That's electric. And he got him a Mark II Jaguar and liked it so much, he decided not to make it electric, and he's restoring it as a regular car.
Oh.
Eric Chris of Massachusetts and Florida, and he made this little piece of polished aluminum bling, which has a Marinco or we put with it a Marinco, NEMA 5-15. NEMA 5-15 is your standard 3-prong plug for 120 volts.
Right.
And Marinco makes a version of it that's kind of peculiar. It's a recessed male.
Yeah.
Like a female male.
Inverted male.
There's some transgender issues and cisgender issues involved here.
Yeah.
But for boats, you plug a cord into the connector on the shore and then also into another connector on the boat, and this is what they use. So for us, it lets us use an extension cord plugged into the wall, and we plug the socket in, the female, into the Marinco recessed male.
Yep.
And that lets us keep a weather cover on it most of the time. And I usually put these on the bumper to charge from 120 on an opportunity charge if I need to somewhere.
Right.
I just like to be able to do that where there's no J1772. Grandma's house, for example.
Yeah.
Unfortunately, now I am Grandma's house, and so we have charging all over the place. But you can imagine. And in fact, I cheat and make up cords that have the NEMA 5-15 on one end and a 1550 range cord on the other end, like an RV Part 220.
Or dryer, yeah.
And so we can charge at 220. That lets us set up and configure our charger and charge our batteries and deal with the J1772 part later, and then the Chatamo part later yet. And so you got the charger wired in. Did you run into any adventures on the cabling of the batteries?
A couple, actually, yeah. There was, as they came up through the box, they were kind of not, wasn't clean as they were going to cross and try and connect onto the terminals. So I pulled them back down through the floor, ran them back up so that they're connecting nice and clean.
Wired in our rear battery box.
Rear battery box.
And you found a contactor up front.
Yep, preventing us from
That's
bringing
hooked
it
up
live.
with our inertia switch.
Yep.
To disable our pack in the event of a wreck. And we also have a switch on the dash, a crash switch, which is kind of cool. And we carry in the store, we sell quite a few of those.
Yeah.
They're kind of a big ruby colored thing.
Yeah, can't miss it.
So it's a pretty switch. And that lets you do an emergency stop. And so we have all that in our high voltage. And then two contactors back here for the inverter, which we don't need today. Right now, we're just trying to get it to charge. When we got the pack all together, what was your voltage?
242, was it?
243.
243?
And that's right at 2.76 volts per cell.
Approximately.
Remember, I got killed on the adding the high molecular weight polyethylene in between each cell, even though it's a 1/16 of an inch.
Yeah.
When we'd done 88 cells, we had 12 cells left over and no boxes to put them in.
Right.
So I tasked Bob with putting them in an ammo case. Where's your ammo case, Bob?
I got one here. Yep.
And actually, you can put 12 in this ammo case, and it looks really good.
Yep.
And he assured me that in his considered opinion, there was no place in the vehicle where that could go.
Other than behind the seat.
And I got tired of arguing about it. So, yeah, he wanted to put it behind the driver's seat where I couldn't pull the seat back. That wasn't going to happen. So we just didn't do the other 12 batteries. We're going to go with essentially a 288 volt system, 88 cells. Now, what we've used for a charger is the venerable NLG 513.
Brusa.
Now, we kind of spotted that in there before I got all the volt chargers working.
Yeah.
But the volt chargers still are 3.3K and water cooled. This is air cooled in a 3.6K. It's an orphan. They don't support them anymore. They don't make them anymore. And the 22 kilowatt ones they do make are kind of set up for 3-phase power in Europe, and they only do about 3.3K here. and they're very expensive.
Ah.
So we're at the end of the Brusas. We have a few left. They're a great charger, kind of quirky setting them up, but once you get them set up, they're kind of bulletproof. Here, we have a Panasonic, what do they call this? A
ruggedized?
Hard book or something?
I just call it ruggedized.
These used to be $5,000.
Yeah.
They're like ruggedized for the military, magnesium case, all that. We have so many calls for Windows XP that, you know, I heard the other day that Microsoft had quit supporting XP, and the Navy gave them a great big contract to continue because they've got so much legacy stuff.
We're dependent
running on XP.
Yeah, our lives depend on XP.
Windows stopped at XP. Nobody gave Bill Gates and those boys the word. They keep churning out. Windows 10 is coming out this month.
Yeah.
And by the way, they're bringing back the start menu because everybody hated Windows 8 so bad. But it doesn't matter. It doesn't get you back to XP, which is the only way they're going to save the company, is go back to XP and issue Service Pack 4 and continue. And I don't think they want to do that.
No.
And so, in any event, I've been fighting this one all day. It keeps going off. But we got a ruggedized, these used to be $5,000, a Panasonic hardbook or something. It's designed for industrial uses and military. Very rugged
Supposed to be
laptop.
able to drop it. We're not going to find out.
We're not going to try that. And I found a guy selling them for $800. Now, by today's standards, they're slow as molasses. But they do have a real serial port on them.
Yeah.
And therein lies the tale. To talk to the Brusa, you have to wire in a real RS-232 serial port, not a USB port.
No.
And so you have to have a laptop that does the serial port. There are adapters. That gets into its own kind of pain in this case, again on compatibility. But we have a real RS-232 cable and a real RS-232 port on the ruggedized laptop, and you wired one in to the amp seal connector for the Brusa Charger.
Right.
And we went through the pain of the NLG Charge Star software.
Yeah. A little clunky.
Again, I demonstrated you have to bring it up and try to connect, then take it down, and then bring it up a second time, and then it connects.
Yeah.
Software bug that's 100 years old and nobody ever fixed. Right now, we have Hyper Terminal up, and that's just an ASCII terminal, and the Brusa gives you a COM1 login.
Right.
And you type in monitor, and up comes this screen. And we plug in the power, and it shows us our voltage and so forth. Right now I have 288 volts. I'm charging the batteries with a battery current of 11.65, 11.5 amps. My charger mains voltage, AC, is 246 volts. I'm drawing right at 14.9 or 15 amps of AC, and we're using 3,700 watts. Again, the volt charger is 3.3.
Yeah.
All of them tend to be 3.3. This is not only 3.6, but sometimes you can goose it a little bit above, almost 3.7 kilowatts.
Is that right?
You can. And so we've got it set up very simply. The Brusa is famous for very elaborate stages you can set up. This made a lot of sense with lead acid batteries, none with lithiums, and I have less patience even with our taper than I used to. We've got it set up to charge to 313 volts, which is 3.55 times 88, which is our number of cells. And when we hit it, we just terminate. Now, I told Bob he could play all he wanted to with the other 7 stages and set up anything he wanted, as long as he didn't overcharge the batteries. But for my purposes, I'm getting more and more where I undercharge them more. And by charging just to their voltage, and not doing the taper, I know I didn't overcharge the cells.
That's true.
And again, we very carefully bottom balanced the cells.
Well, he did last weekend.
And re-bottom balanced them. You did.
Yep.
Just last week. And so they were at a rock solid 2.75 plus or minus 0.05. And when you put all that together, we were measuring 243 volts when we hooked it up. And what we saw on the screen was within a half a volt to what you measured at the posts.
Yep.
And so right now, we're actually going to watch it charge and make sure that it does indeed in front of us with our eyes, not in our heads, with us here.
Not with the fire department letting us know.
Right, not phoning it in. This is an important part. Certainly the first charge, however many Brusas I've used, and however much I know what I'm doing, we're going to actually stand here and watch it reach 313 volts and start to bring the current down, and then it should terminate and just drop, and that be it.
That would be as planned.
And it not do anything further.
Right.
And that's an important thing. The first charge, if this is your first build, let's say the first 3 charges, I want you to stand there at the end and watch it terminate. After you've seen it do it 3 times,
then you can pretty much be
It's probably
assured.
going to do that every time.
Yeah, yeah.
But things happen, and they're expensive batteries, and if you overcharge them, they die. And so the most important part of battery care is to terminate the charge before you overcharge the cells.
Right.
And almost all the chargers we sell have got a very good reputation. We have many years of dealing with all of them except the Volt, and I've spent 100 hours playing with the Volt, and it seems to, it doesn't even tell me what the voltage is, but if I tell it what voltage to finish at, it hits it within about a volt.
Yep.
A volt and a half.
Yep.
And it's very good about that. And so I like that about the Volt charger. So we don't deal with some of the chargers that are out there that you may find otherwise popular. There's a reason. It may not be a very good reason, but it's a reason. And so I do like the Brusa. We've got a handful of them left. They're great little chargers. Their day is going away, and they're kind of an orphan. And again, I want us to work towards parts that after Jack is passed on,
yep,
and your kid's driving your electric car, and nobody knows nothing about it, if the charger goes out, they can look on it, see a GM part number, and just go get one.
Yeah, exactly.
And plug it in. And
chances are there will be some around.
99% chance they'll be back in business. So more standardized parts that are more widely available, less orphans that have been abandoned by companies that were trying to be in the space.
Too soon.
And so that's, you know, we were delighted to get things like the Zilla controller and the Brusa Charger and so forth when they came available.
Best in their day, right?
They were a huge advance. A pulse width modulated controller, how efficient could it be? And so forth. But those days are past. Technology marches on. The adoption curve proceeds. And so now we can get better, and it's not even better, it's just more widely available. We're not even getting them off eBay anymore. We just order Volt chargers from the dealers. Put our little controller with it and ship it.
Yep.
And it works. And if it quits working, if it's the charger, you don't have to call me.
You know where to get them.
Take it down to GM.
Yep.
And they'll replace it. I suppose my controller could go bad, but it's very low power, low current, low everything. It's just not going to be much stress on it.
Yeah.
The power electronics are the charger. So that's what we've been doing, is getting the charger going. Next, I guess the DC to DC converter.
It's, kind of what we're looking
let's
at
get
right now.
12 volts up.
Yeah.
And we'll have an up pack and up 12 volts, and that's what we need to install and test the remaining
Finish the rest of the car.
And finish the car.
Yeah.
We have mounted our motor and inverter, our chill system, coolant system. Again, I've seen a bunch of you putting together a cooling system that goes through the inverter first and then the motor quite properly. We have found that those are problematical. You kind of need a separate.
Yeah.
And what we have in this one is actually a dual heat exchanger. It has 2 separate loops in it. But we have separate fill tanks, separate pumps, and so
2 completely separate systems.
And it's because the temperature zones they operate in are completely separate.
Yep.
80 degrees, all the inverters die. They go into current limit. And the motors can do 180 degrees centigrade. And so we just wind up with the motor heating up the inverter until the car won't go.
Right.
Well, what's that about?
Doesn't do us any favors.
Doesn't do us any good.
We don't want to limp home.
So we're going to a dual system, which is not what I wanted. I didn't want any fluids in my electric car at all. But it's a big boon on the freeway because we can go a long distance and keep our drivetrain cool, which is what we couldn't do with the DC motors.
Exactly.
I like the DC motors, but I couldn't cool them.
In the quarter mile.
And in the quarter mile, they're great. In 45 minutes on the freeway, man, do they get hot.
They're hurting.
And there's no way to cool them. We put blowers on them and everything, and just wasn't doing it. So that's the progress on the green thing. Today is Charger Land, and good work, Bob.
Thank you.
We're charging. We have a wired up battery pack, strapped up, bottom balanced, hard installed. The other thing I'm seeing a lot of is people still like those open battery racks.
Yeah, like
with the angle irons on top coming right up against the terminals.
Yeah, not good.
I get a chill every time I see that.
Yeah.
I think they get away with it. It's probably okay, but it just gives me the memes. For years, we make a aluminum box, usually out of .090 or even .063, but usually .090 aluminum, that comes up 2 inches above the battery terminals. And so the closest metal gets to the terminals is the side of the box, which is the far edge of the battery.
Right.
All our angle iron lid and stuff is 2 inches above the battery terminals, and it's all enclosed.
Yeah.
And one thing is it keeps our batteries from getting nasty.
For one, right?
Dust and everything going to get in there. Our batteries always look good.
Maintain the environment, right, with the heater pads and you know.
Yeah, it lets you do things like electric heat and so forth. So I like enclosed battery boxes where hands can't get to them. Wrenches, eyeglasses, ballpoint pens,
road debris,
and
whatever.
All akimbo cannot get to my batteries very easily. They have to fight their way into that box, and
they're pretty nice boxes.
And they don't really cost any more than all the angle iron welded up together. We don't even do them in house. We just order them in, and we do all the truck bed liner, the angle iron, the lidding, and the connectors or gland nuts, cut holes in them. We basically build the box, but we start with a box. It's already welded up. We don't have to actually weld them. What I found was by the time I bought the materials and had somebody in here that could weld them, the guys at Southeast Fabricating could do them for less than my cost on the materials.
Right.
Because they buy the materials by truck. And they're marking it up 100%.
And in half the time.
Right. Well, no, sometimes I'd have to wait a week or two because they kind of work me in to keep people busy when they don't have anything else doing.
They've got, some pretty big projects going on.
You want to put a rush on that, you talk about some charges, then it gets expensive. but they're they run 125 to 250 bucks a box, and we use kind of big boxes.
They're well made. They're done. They're nice.
Well, like I say, we do most of the fit and finish here, but they weld us up a nice strong box to start with. And I like them enclosed. I don't want to see those cells. I don't want to drop stuff in them.
That too, and and it's more of a factory look. We want to go for the good look.
It is. It does look good. Yeah. And so, but anyway, we're charging ahead, so to speak, with the green thing, and I hope to have it on the road. We have a number of UQM projects on the road now. Of course, we had Oleg in Russia,
with that
Moscow.
Military.
But now Colin's doing one with the SL190, and Rich Morris has got one up in Madison. We've never gotten ours going.
Won't be long now.
Rich panicked me, said that he was having problems with the UQM quitting on him right away. And so I went through a big evolution this week to get the UQM bench back up and running, and we did.
Yep.
And then we found out it was a contactor issue with Rich, and he got that squared away, and he's driving like crazy now.
Good.
So, but I do want to get our UQM rolling test bed on the road where I can duplicate things that these guys run into.
Yeah, exactly.
That's the idea.
Plus, it's been in the shop for too damn long.
Well, we got a lot of things that have been in the shop too damn long, but this is going to be it was always going to be a great build. We found a really nice VW thing to start with.
Yeah.
And you start with a better car, you wind up with a better car.
I think that's the key to any conversion, right? Is to start with a great foundation. Don't do your 73 Pinto. Do something that's, do the restoration first and then do the build.
Right.
And do the electrics.
And we put all new running gear on this, brakes, brake drums, new shock absorbers, axles, transmission, the whole thing. Right down to a sway bar you finished off with. So it should be a good roller, and I'm hoping that UQM motor makes a very smooth driving VW thing. This one I can take in the rain.
Yeah.
Stay with us. I have said a number of times that basically when you get the batteries in and the battery box done, you know, where they all go, and you get them in and strapped up and bottom balanced, you're between 70 and 80% done with the build. Bob doesn't quite believe this right now. It looks like chaos. But,
there's still quite a spaghetti bird's nest in the dashboard, and actually the Jev cube and the inverter, and
I know it always looks that way, Bob. But you'll
one
see,
wire at a time.
If we sit there and do one wire at a time, and it takes us 10 or 15 minutes to figure out a wire, that's 30 wires a day.
Yeah,
we don't have 60.
Yeah, exactly.
So I mean, it's if you spend 15 minutes a wire tracking it down and getting it hooked up and trying to figure it out, and that's 4 an hour, is 32 in a day. And if you have 100, that's 3 days. You've been working on this car for, in this case, a year, but in normal case, 3 months. And to do all the wiring of the whole car takes 3 days.
Yeah.
Of concerted effort. Say it's a week, it's still a tiny percentage of the time and effort to do it because of wrestling those batteries around, and that motor adapter to the transmission is about 10% of the build. About 80% of the build is the batteries and battery boxes and charger.
Yep.
And the last 10% is all the rest. But it just falls down so fast that you can't, it won't we could be rolling easily in 2 weeks.
Well, I hope sooner, but we'll see.
We might.
You eat an elephant one bite at a time, right?
You do, but this elephant is very misleading, and it discourages people. They've been battling for 4 months and have just now got the batteries in and the charger hooked up. No, you don't understand. It's over. Once you have a high voltage pack, to get 12 volts is a couple hours.
Yeah.
And once you have 12 volts in the high voltage pack, everything you do counts.
Connected. Yes. And yes, you'll see.
And you take off at a gallop, and it's a week of wiring. And I mean, if it's from scratch, I know it looks like a rat's nest. We're never going to get it straightened out.
We will.
It's actually almost trivial.
You're right.
It's the big end of this is always the big end of an electric car is the batteries. The big end of the work of making an electric car is the batteries. The rest of it is. I always find the mechanics of mating the motor to the transmission always mystify me, but that's
done.
You know, well, it's done in this case, but it always works out. I don't know why it throws me so bad, but I just don't think mechanically. And so, but there you have it. We did the battery pack in, sacrificed 12 cells.
Yeah.
Which, see, we use 60s in the yellow thing and 72s in this. So our net pack size will be the same.
Okay.
But we'll be a little lower voltage.
Yeah, though, right.
But I don't think that's going to limit us at all. We'll see, but I don't think so. Yeah. And we have a few complicating factors.
Oh, yeah.
Jeff Southern made us quite a heater. We have battery box heaters involved in this case that we could spend some time on. We have the Chatamo, which is going to complicate things a lot, but doesn't have to really to get it rolling.
Yeah, I mean, right. It could be
almost an after project.
Yeah.
And then it'll be an easy after project because we went ahead and installed the wires and stuff.
Yeah.
the inlet.
It's in there.
And so forth. And the we're going to make a run, and this is all on Bob. He has devised a panel to go into our dashboard with an electric vehicle interface from Andromeda Interfaces.
The EVIC. We'll probably have something next week to show about that. It's
and that'll
hopefully it fits
display the data very nicely. I did have a couple of just viewer comments come in over the transom. One was that we've kind of gone off and left our low voltage guys.
The sub 200s, you mean?
120 volt AC 50 systems.
Yeah.
And so forth.
Well,
I don't like to say it isn't so, but yeah, we did. We went off and left you. Hey, no, we're
still here for you. But,
I understand we have several vehicles here that run in that scheme, and we love them.
Yeah, they're fun.
And in fact, my Escalade, the daily driver, is actually a Series DC with a 197 volt system in it. Why are we going to higher voltages and AC systems?
Natural evolution.
If you want to fully participate with the infrastructure and the support that is going to emerge courtesy of Nissan and BMW and Ford, and General Motors and Tesla for electric vehicles, and not be kind of a second-class citizen with a bastard one-off thing. We're going to have to evolve in along the same lines that they evolve. And that means often, hopefully, using their batteries and their chargers and their motors.
Their parts.
And their parts.
I mean,
now, I think this is going to be a challenge, but it will lead to better builds and fuller participation in charging networks of the future, for example.
Right.
But it almost goes beyond that. It goes to the future of automobile parts. View the supporting infrastructure as being Napa and Checker and O'Reilly's and the dealers and the whole thing worldwide with accessories and tools and parts that we have in common with them. And so we don't care. If you use a Volt Charger, you'll be able to get it in. And we can mix and match.
Yeah, that's kind of one of our cool things.
Right. We can put a Volt Charger. No, wait a minute. I went 10K. Let's put 3 Volt Chargers.
Yeah. Yeah.
Right. A Tesla drive unit. A Nissan DC to DC converter.
You make them all.
An air conditioner out of a Kia Soul.
Right. Yeah. These are doable. This is what we're doing.
Right?
Yeah.
No, this sounds facetious.
This is the road we're going on.
This is the road we're going on.
Yeah.
And so you'll have the full panoply of OEM components appropriate for electric cars to select from in doing your design of a 59 Apache.
It's modern hot rodding.
It is modern hot rodding.
You know?
This is hot rodding the next level.
Exactly.
I think of it as custom cars, but
yeah,
you know, custom EVs. But yes, if you must use the hot rod concept, but and I even beloved cars of the past, 68 Camaros, 72 Roadrunners.
Oh, right.
Not super exotic Mercedes
$1 million cars, right?
I'm just talking about. I often drove a Falcon when I was a kid. I'd like to do a Falcon.
Yeah, okay.
Just because.
Put it on the list.
I used to do Falcons. Maybe a Pinto. I don't know, but cars with character and from the past. Rich Morris. I would never pick a white pickup. If I did a Studebaker, it'd be a 55, not a 60.
Yeah. Run what you brung.
It's his car.
Yeah, you run what you brung.
But I can guarantee at this point that it will be a very rare day where Rich Morris will pull up and get out of his white 1960 electric Studebaker Champ and find a yellow one just like it
next to him. Yeah, right?
That's not going to happen.
Nope. It's a nice little truck.
And it makes quite a statement. Here's the part we don't really talk about at EVTV, because it enrages the people that drive Teslas and Leafs so badly. It's kind of a statement when you pull up and get out of one of these cars. And the statement is, I don't send my money to a bunch of raghead ISIS Iraqis.
Sympathizers. Yeah.
Right? I don't approve of sending other people's children to the desert to get parts of them back.
Yeah.
For oil. And I don't really approve of fouling the air. I may be on the side of the global warming, and I may be against global warming. But I know what it smells like out the ass end of a Dodge Ram Charger.
Right. Right.
And it's bad.
And the fact that I don't have to go to the pump anymore.
Right. And I don't go to the pump, and I don't do any of that, and I did it with my own 2 hands.
There you go.
And I didn't just go write a check for a Leaf.
Right.
Or a Tesla. I went in my garage, made my own damn car.
I built it, yeah.
And
nothing more satisfying.
Do with it what you want with the information.
Yep.
Now, in a world of advocates for the environment who are busy saving plastic bags by carrying their groceries in jute bags.
Yeah.
That's what they think saving the planet is for.
Right.
You get out of your goddamn pickup truck and slam the door.
Yeah.
Bam.
And you're
it's different.
Yeah.
If you're a little confused at how different it is, that canvas bag ain't going to help you.
And styrofoam isn't going to matter.
If you want to do something to matter, this is what you do.
Yeah.
And if you can affect those around you to do likewise, it's even more so.
Come and join the Army, guys.
Come and join the Army.
Yep.
It's good to be in the Army.
Very much.
You don't really have to apologize for it.
Yeah, right? In fact, you can stick your chest out a little bit for it.
Yeah, it's just, it goes, there's some personal satisfaction that goes a lot of different directions in this thing. And it's tough to put it in a capsule for people, why guys do this. But it works really well. Stay with us.
Yep, that's about it, huh?
We'll do more of it next week. How about that?
I'll show you some EVIC.
Right here.